I ask you to add up the first 12, which I didn't, first 12, extend this out until you have 12 terms. You're going to sum them all up and give me a grand total. Why not, if the formula's staring at you, just put a 12 in here, 12 times, I guess, 23. When you do the math here. Is that true? So 12 times 23, whatever that is, that's the sum of the first 12 back there. Philip, would that help if you had the formula? Okay. I like this also. Where you write it with the sigma notation, get the answer, but then also I love this too, where they might give you a formula that works. Now the trouble is, will this formula always work? Will it work for all positive integers? That's what we have to prove. Okay, right quickly, before I jump into the proof and close this down, because it's getting a lot too heavy. Can anyone tell me right quickly, what would be the sum of the first 50? Can you imagine? The first 50 terms. I know that's 19 there. That's the 19th term there. Suppose I go further, all the way out to the 50th term, and ask you to find the grand sum of the first 50 terms in that expansion. What should the answer be? It will replace n by 50. So it'd be 50 times, I think, what, 99? When you replace n by 50, is it 50 times 99? I'm trying to do the math here, just standing here. 4,950. I did that quickly. That's the sum of the first 50. Please tell me, is that a benefit if that formula is given to you? Rather than you doing it this way. I think so. Adrian, does it always work? Here's what we're going to do. Induction. First step, induction. Show that that statement is true at or for the beginning, when n is 1. That's the easiest part of this 3-part induction, they call it. Guys, the first term on the left-hand side is 1. Just trying to establish it's okay at the initial beginning. Jump to the right-hand side, replace those n's by 1, you get this, which I think is 1 times 1. You do the math, you get 1 again, put a little check mark, you've established it initially on both sides, it works. Secondly, here's my little story behind this to close this down. I would now start with Mr. Park, and I say, Mr. Park, we've proven it's true at the initial. Now I would say, Mr. Park, could you add up the first two 6 and verify at 2 is 6? You would do it for me. Okay, Arena would do it for 3. Now I go all the way through my class like I was telling you yesterday. Get over to my last student. Let's say my last student is number 25. And the students say, is it true at 25? Well, that's going to be a little demanding, but that student has to add up the first 25 terms for me, and then put 25 in here, and see if we get the same answer. Now, am I satisfied then it's always going to work? No. Is it now going to work for 26? So you got to go back through 26, 27, 28, all the way back through. Let's say the last student at this time would be 33. That student has to add the first 33 terms. This is just 19 here. 33. Say, Professor, give me some time. I'll add them up for you. Get a grand sum. And then they got to go over, put in 33 here, Philip. And hopefully when they put 33 in here, they got the same answer as when they summed up the 33 terms. Now, am I happy it's always going to work? No. They're saying show it works always. We can't do it always. And how many positive integers are there out there in the universe? Infinite. So I can't go through the class over and over and over and over and ask them check and check and check. So what's this induction proof going to do for me? It's going to prove, hopefully, in these 3 steps, it always works. Guys, the first step is easy. At the beginning, initially, it makes sense. Now, assume. I don't like that word. I don't like that word. Because after grades are posted, you may have assumed you got an A. And all of a sudden you see Canvas gave you a, I don't like that word assume. But, Nima, I have to do it. I have to assume that yes, my 25 students have shown at least the first 25 it works. So we have to assume. We have to assume the statement is true up to a certain point, and that certain point will be identified as, they call it, up to K. We'll assume it's true up to K. My K would be 25. My 25 students have checked it, it checks out, therefore I'm assuming it's true up through 25, but is that officially finished? No, it's true now 26. It just keeps going. So we're going to assume it stops at a certain point here. How does it look at K? It looks like this. 1 plus 5 plus 9, so forth and so on. Right for me. Up to, here we're going to put a K in there. 4K, subtract 3. And the other side of the K is K times 2K minus 1. With that, just replace N by K. I'm assuming that is true. Up to that certain point K, that my statement is true. I'm assuming. These two steps, if you see an induction proof on the final, these two steps are a given. Can't miss those. It's the next step, the last step. Now you gotta show the statement now is true. And some of you guys may remember what happened. What should I assume after the assumption? What should I now try to show next? It's true at K plus 1. You keep going one more. My 25 students have shown it's true, now it's true for 26. And we go all the way through the class again, now it's true for 42. So this is written as shows a statement is true at N is equal to K plus 1. You keep going, one more. Now I like to do this. I like to draw an arrow to show you. I'm just rewrite. We've already assumed this, so we'll just rewrite it. 1 plus 5 plus 9, so forth and so on. I will not get heavy on this at all in the final. We've already assumed it. That's true. Now I'm going to add to it though. Can anyone tell me what the next term would look like? Now I'm going up to one more, called K plus 1. What might that look like? Help me out. At K plus 1. Where my last term is expressed like this. I think I heard it. Could I go to that last term and say, Professor, are you looking at replacing N by K plus 1 to see what it looks like? Is that the way the terms look at K plus 1? Go to my formula, put in K plus 1. Clean that up. Guys, you're going to get 4K plus what? 1? Therefore, I have now 4K plus 1 on that side. That's a K plus 1. I just extended it one more, and I'll put in K plus 1 to see what that would look like. What does the other side look like at K plus 1? Well, the other side was this. What's it look like at K plus 1? Replace those N's on the other side by K plus 1, and you get this. Now watch carefully, we're about to finish this up. K plus 1. Inside here, I got 2 times, I better write that, K plus 1, subtract 1. That's what this side looks like at K plus 1. That's what this looks like at K plus 1 on the other side. Wow, wow, wow. I had to show you an induction proof to close this down. If I can show those two sides are equal, we're finished. We're finished. If I can show those two sides are equal. Here we go, guys. The red. Watch carefully. All this from step 2 was the assumption. We said all that's equal to, if you wish, I could put this in place of all that. Step 2 says all that I just underlined there can be written as, if you wish, K times 2k, subtract 1. I still have the green being added to that. So all that underline came from step 2. Guys, I'm going to stick with that side there on the left, clean it up a little bit, and see if I can get some things to match up here. We want these two sides eventually to match up. Hang on. I'm running out of board space here to clean this up. Guys, left-hand side, just focus on the left-hand side. And we use the distributive property and end up with 2k squared subtract k on the left. Distributive property. I still have in the green to add to it on the left, this 4k plus 1, which will give me, hang on, will give me, I'll put the equals mark here, will give me underneath this 2k squared plus 3k plus 1 on the left. I don't have anything on the right written yet. Guys, I think 2k squared plus 3k plus 1 may factor. I'm going to try to factor it into and see if I get this right. Try k plus 1 and 2k plus 1. We step back and see if I did the factoring correct. Is that going to factor into that? True? Now move to the right hand side. What you're hoping is after all that work you did on the left, when you clean this up on the right, they agree. Okay, on the right, I have k plus 1 in the green. And inside there, inside the brackets, I've got 2k plus 2 right here. Of course, subtract 1. Guys, 2k plus 2, then subtract 1. Will that give me 2k plus 1? Are the two sides the same? They call this induction. You may have another name for it that I don't want to hear. If you get down to this point and these two do not match up, you might use another word, which might not be very pleasant if they don't match up. When they match up, you smile and say, oh my goodness, the two sides match up as they said they should match up. And we get by induction. Okay. Wow, guys, I hit you hard today. I hit you hard. Chapter 11 is finished. Chapter 11 is finished. Let me check. He said, Professor, please, chapter 11, please. Because the course is almost over, Professor. Please don't throw anything else at us. Let me check and see. I think. Nice. Oh. I do see one more thing here. This is not hard though. One more thing before you close down. I know we got about 5 minutes. It's going to take us about 5 minutes. Now, if I were a student, Jonathan Express student, if I were a student, my concern right now would be when I take that final, you say, Professor, I'm still concerned about, will I be able to come up with this formula? You show me a shortcut here, it's called arithmetic, or maybe a shortcut I can fill in and find the formula. So it's not arithmetic, Professor. It may take me some time to play with those numbers and come up with a formula. That's the problem of these. Now, the way I'm going to close this completely down, just on in my notes here, more than likely, more than likely, of course you'll have something like this just to set it for me. I'm not going to ask you probably to calculate the number there. But, here we go. They have in your textbook, they call it this, you may use a recursive setup, a recursive formula. That's not really a formula, but I'm going to call it recursive. And you'll see why they use the word recursive here shortly. Jonathan, this is for you. Here we go. Given here's what you want. Given a subscript 1 has a value of 3. It's going to be a bit all the And then all of a sudden, they write this for me. A subscript n is equal to 4 subtract a subscript n minus 1. In essence, they've given the formula to me. A little strange written like that, but they gave me that. They gave me the value of the first term. That's a subscript 1. That's the first term of this sequence. And then they all of a sudden looks like they're trying to give me a formula written a little different there, a subscript n. And then they're asking me to please write, I think I did this, I did, write the first 4 terms of this. Add in chapter 11 of this. Now, got 4 terms. This is a sequence, not a summation. First term, 3. They gave that to me. Now, second term. Now, I have to sit there and try to come up with a formula. They've given the formula to me. Second term, here we go. If I follow this formula, it's given to me. I'm going to label it like this. I'm looking for the second term, so a subscript 2. That's the second term. By formula is 4 subtract a subscript 2 subtract 1. Let's replace n by 2. I'm going to go to the second term. Do the calculation. This is 4 subtract a subscript 1. Thank goodness they gave me a subscript 1. I can finish this up, write this as 4 subtract, and they gave me a subscript 1 to be a 3. Do my calculation. The second term has a value of 1. Philip, you're close by here. Let's find the third term. A subscript 3. Same formula, right here. So it should be 4 subtract a subscript 3 minus 1. Clean this up. 4 subtract a subscript 2. Philip, 4 subtract what is a subscript 2? What's my value of my second term? 1. Put that in there. My third term has a value of 3. That's true? And the fourth term, a subscript 4, by formula up there should be 4 subtract a subscript 4 subtract 1, which is 4 subtract a subscript 3. 4 subtract and a subscript 3, I just found to have a value of 3, and it looks like I'm going to end up with, there's no mistake, 1. Now, can a sequence do that? It certainly can. They can repeat. I use my formula. Now, guys, if I give you a formula, in fact, I'll give you maybe the first term and ask you to write from that first term the others. Can anyone tell me the risk being done here? How could you miss it if you see it on the final exam if the formula has been given to you, which is a plus? But what's the risk? In finding the values of those remaining terms. The formula's given, you're happy about that, but there's a risk. What's the risk?
If you mess up on the first term that you want to find, then the rest are going to be incorrect.
Exactly, exactly. If you make a mistake down here, you're not careful, and you did not get 1 here, which second term was supposed to be 1, for some reason you messed up and you got 2. Then you're using that to find the next term. Well, the next term's going to be wrong also. Next term's going to be wrong. So you've got to be very careful, even though that formula's given to you. Because one wrong answer could affect all those. Now, the last one here we go. I know. On the side here. Given. A1 has a value of 1. A2 has a value of 1. a subscript n is equal to a subscript n minus 1 plus a subscript n minus 2. Now, they have given me, we'll just write out a few of these terms and we'll take a break here. They have given me the first two terms. They're both ones. I'm going to start with the third term. The third term's missing. They gave the first two to me. If I go here and try to apply the formula, I'm looking for a subscript 3. It's missing. The formula says use this. So it's going to be a subscript 3 subtract 1 plus a subscript 3 subtract 2, which is a subscript 2 plus a subscript 1. Is a subscript 2 and a subscript 1 the numbers they gave me to begin with? So this says the next term should be 1 plus 1, which is 2, and that's my next term. The next term, let's find one more, a subscript 4, by formula, it should be a subscript 4 subtract 1 plus a subscript 4 subtract 2. That's going to be a subscript 3 plus a subscript 2. A subscript 3, I just found it. That's the third term. I hope there's no mistake. It's going to be a 2. A subscript 2, they gave to me. It's 1. Add them up, you get 3. And I could continue with this. Guys, what's that going to finally turn into? What's that going to finally turn into that we discussed yesterday? I stopped at the fourth term, I guess. Does anyone have a guess as, without using a formula, what might be the next term? We sort of saw a glimpse of this yesterday. What might be the value of the next term after the 3? 5. What might be the next one? 8. 13. 21. Was that Fibonacci? Was that the Fibonacci sequence? Except now they may have it written up like this. So you can apply a formula. Barbara.
Is there a formula for the nth term?
It's beautiful. Which term do you want to be the nth term?
50.
Yeah, you want, maybe you go and find maybe the 50th term in Fibonacci's sequence. And you're saying, Professor, is there a standard formula I can find somewhere? AI may give it to you. Where I can just plug in and find the value of any of those terms in Fibonacci's sequence. I have not seen one myself directly. I don't use one directly. And I would never ask you to find the 50th term of Fibonacci's sequence. Mr. Park, we're going to take a break here. Time for a break here. But do me a quick favor. Do some research on Fibonacci.